When naming an organic compound, we generally identify what is called the parent chain. Then, we name the parts of the compound which are branching off of the parent chain. These are called substituents because they substitute a hydrogen on the parent chain. Hydrocarbon substituents are called alkyl groups. Let's learn some of the smaller, most common alkyl groups in this video. First, think of an alkane. Here are methane, ethane, and propane. Alkanes are saturated hydrocarbons, meaning they are comprised of only carbon and hydrogen atoms. And each carbon has the maximum number of hydrogen atoms around it to satisfy the octet rule. Thus, there's a maximum number of sigma bonds. You can see my lecture on hybridization for more on sigma and pi bonds. Now, imagine removing one hydrogen atom. These are now called alkyl groups. Notice the suffix change: methyl, ethyl, and propyl. Here are the 4 and 5 carbon alkyl groups, butyl and pentyl, respectively. Let's go back to the methyl example. Since a hydrogen is removed, the carbon is now allowed to bond to a parent chain, and this is considered a substituent. Here's the example of the ethyl substituent. Now, we must take a deeper dive into alkyl groups with 3 or more carbon atoms. Consider propane. It has 2 primary carbons, see my lecture on classification, and 1 secondary carbon. Removing a hydrogen from a primary carbon yields the propyl group. This is considered a straight chain alkyl group, where all the carbon atoms are bonded in a straight line. However, notice that removing a secondary carbon yields a different alkyl group. You can imagine when branching off of the parent, the substituent branches again. The name for this alkyl group is isopropyl. Iso is not a prefix, but rather part of the name. Use the letter I when listing in alphabetical order. Now let's consider the 4-carbon alkyl group, and things get much more interesting. Butane has 2 primary carbons and 2 secondary carbons. Removing any one of the primary hydrogens yields the straight chain alkyl group butyl. However, removing any one of the secondary hydrogens yields another branched alkyl group called secondary butyl, or sec-butyl for short. Sec is a prefix we add, thus sec should not be used when listing alphabetically. Use the B in butyl when listing alphabetically. We are not done with the 4-carbon alkyl groups. See, 4 carbons can also be arranged like this. In this example, notice a tertiary carbon. Interestingly, you can think of a carbon bonded to 3 methyl groups in this specific alkyl group. Still, this bonding pattern is bonded to a parent chain. This is called a tertiary butyl, or tert butyl for short. Again, tert is a prefix and should not be used when listing alphabetically. And there is another bonding pattern for the 4-carbon alkyl group. Consider this bonding pattern. Does it look familiar? It should. It looks like an isopropyl. However, there's an extra carbon between the 3-carbon chain and the parent chain. This would be considered a 4-carbon substituent, and it is called isobutyl. Like isopropyl, I should be used when listing alphabetically. 5-carbon substituents can be complex. Here are some of the common bonding patterns starting with the straight chain alkyl group, pentyl. Consider isopropyl and isobutyl. Add another carbon between the 4-carbon group and the parent chain, and you obtain isopentyl. Finally, consider tert-butyl and add another carbon between the 4-carbon group and the parent chain, and you obtain the 5-carbon group neopentyl. The names I use are all common names and not IUPAC names. The common names are so common that they are acceptable by IUPAC. Now, let's try to identify these substituents.